All right, guys, we're going to jump into different type of sequence now. We've kind of talked generally about different types, explicit and recursive, but there are actually different types of sequences within those two classifications. So let's just maybe to quickly review one more time. I know I'm kind of hammering this home, but to the extent you don't have a good understanding of explicit versus recursive, it makes everything else we do after this pretty difficult. Okay, so define an explicit sequence. Okay, if you remember, right? An explicit sequence is a sequence, right? Sequence where the value is found by its place in the sequence. And the place in the sequence. Okay, so an example of that might be a sub n equals 4n minus 6. Right, if you want to find the 10th term, you just plug in 10 for n and you have the 10th term, and that's really nice. Okay, recursive, right, you will remember, is a sequence, right, a sequence where the term is dependent. The term is dependent on the previous term. Okay, so an example of that might be a sub n equals a sub n minus 1. Remember that a sub n minus 1 notation just means previous term. So take the previous term and add 10 to it, but as part of the formula, you have to give me a number to start at. So maybe, for example, you tell me the second term. So if I know the second term is 3, then I know the third term must be 13, the fourth term must be 23, and so on. Conversely, if I want to find the first term, subtract 10, that must mean the first term must have been negative 7. Okay, so that's the difference between recursive and explicit. You really got to know those well, okay? All right, so certain sequences I wrote here have different types of names depending on their patterns. So one common sequence that you might see maybe in real life, you won't see it that much here, are repeating ones like 0, 3, 0, 3, 0, 3. That's what we call an oscillating sequence. We're not going to do a whole lot with those, but I do want you to know the name of them. Oscillating means like back and forth, so it kind of makes sense. It's going back and forth between, in this case, the two numbers 0 and 3. If we look at the next one, 1, negative 2, positive 4, negative 8, positive 16, negative 32, positive 64, and so on. Right, it's kind of going back and forth between positive and negatives. Call that an alternating sequence. An alternating sequence. Ones where it shifts or goes back and forth between positive and negative. All right, so then I asked the question, what do the following sequences have in common? And you can see those three sequences down below. And I actually want you to pause the video for a second and see if you can find the commonality among all three sequences. And mainly I'm looking for maybe the difference, or how much do they increase by in each of these sequences, or decrease? How much does it change? So I'll encourage you to pause it, see if you can come up with a commonality amongst all these three, and then see if you and I get the same thing. All right, so hopefully you paused it and checked it out. And if you look at that first sequence, you'll notice it looks like every single one increases by 4. If I look in the middle one, everyone increases by 7. And then if I look at the last one, everyone decreases by 5. So what I would notice or might want to say about this is that in each sequence here, okay, so in each sequence, okay, the difference between the terms is the same. Now, not to say each sequence increases or decreases by the same amount, but within each sequence, to get to the next term, you would increase by the same amount each time. All right, so that's a specific, or those are specific types of sequences, okay? And those type of sequences are called arithmetic sequences, okay? Because they all have what we call a common difference. It's kind of a fancy math speak for like just increasing or decreasing by the same amount. Common difference, and we denote that with the letter D. So if you see the letter D, We're really just asking what is the common difference? How much are they increasing by each time? How much are they decreasing by? So what is D in the sequences above? So in the first one, 1, 5, 9, 13, 17, D would be 4 because each one's increasing by 4. If we look at the second sequence, 6, 13, 20, 27, 34, each of those is increasing by positive 7. And then in the last one, negative 4, negative 9, negative 14, negative 19, negative 24, all of those are decreasing by 5. So D would actually be negative 5. D can be negative. Okay, it can be negative. All right, so those are some examples of sequences kind of written out. But what if I gave you some formulas, like the 4 I listed here? Are these arithmetic? Are some of them arithmetic, some of them not? All right, so I would again encourage you to pause the video here, see if you can determine which ones are arithmetic and which ones are not. All right, hopefully you did it, and I think the easiest way to prove whether they're arithmetic or not is to find the first few terms. So in the first one, a sub 1, I'd plug in 1, 7. A sub 2, 4 times 2 is 8, plus 3 is 11. And a sub 3, 4 times 3 is 12, is 15. It looks like they're increasing by 4 each time, and that really shouldn't be a surprise. I have that 4 in front of the n here, so that's kind of interesting. So we'll hold off on that, but that one is definitely arithmetic. So it says circle the ones. Let's follow the directions so we don't get in trouble. Okay, that one definitely is arithmetic. For the next one, we have a sub n equals a sub n minus 1 plus 5, where a sub 1 equals 4. This is this is a recursive sequence. Let's find out if it's arithmetic by looking at the first term, which was given, which is 4. The second term would just be the previous term plus 5, so 4 plus 5 is 9. The third term would be the previous term plus 5, which is 14. So it looks like each one of those is increasing by 5. Okay, so certainly that is arithmetic. Where do we see the 5? Looks like it's being added there at the end. So notice in a recursive sequence, arithmetic sequence, the number is added at the end, whereas if it's written as explicit, it looks like it's the coefficient in front of the variable. Let's take a look at a to the n squared plus 1. So let's find the first term. 1 squared plus 1 is 2. Second term, 2 squared is 4 plus 1 is 5. If I look at the third term, 3 squared is 9 plus 1 is 10. So if I'm looking at the difference between these, it's 3. The difference between theirs is 5. So I do not have a common difference between them. So I would have to say this is not arithmetic. And then if I look at the last one, a sub n equals 7 minus 5n. Okay, let's try to find some terms. A sub 1, by plugging 1, 7 minus 5 times 1 is 2. A sub 2, 7 minus 5 times 2 would be negative 3. 7 minus 5 times 3 would be negative 8. So it looks like all of these are decreasing by 5, which again, I see there. Is this an arithmetic sequence? It is. Okay? So interesting that it looks like it was an explicit arithmetic. We have a number, a coefficient in front of the n. Doesn't look like any squareds can be arithmetic. And if it's recursive, I'm going to have a number either added or subtracted the previous term thing. So a sub n minus 1, we had a number come after it, the 5. That's where our arithmetic came from. All right, so those are arithmetic and arithmetic sequences, both recursive and explicit. Let's take a look maybe into a few of the problems, and then we'll be done a few problems for how you might see this, and then when we come up with a general formula for actually finding arithmetic sequences given a problem. All right, so it says the fourth term of a sequence is 20, the 13th term is 65. Write the first 5 terms of the sequence. Interesting. Okay, interesting. Well, it's an arithmetic sequence, we're told, so we know it's going to increase by the same amount. It's going to change by the same amount. And if we know something's going to change by the same amount, we can actually use something called this slope formula, which I'm sure you have used before. In fact, I know you have. So all we're going to do is take the change. Okay, well, that's a bad change symbol. All we're going to do is take the change in my numbers over my change in my terms to find d. So I had 65 and I have 20. I want to know the difference between them. 65 is the 13th term. 20 is the 4th term. So I'm basically doing the change in the numbers over the change in the terms. I get 45 over 9, which comes out to be 5. That is equal to my d value. Okay, that's how much it's changing by. It's increasing by 5 every time. So if I know the 4th term is 20, and it's increasing by 5, that would make sense that the 3rd term then must be 15. The 2nd term then must be 10, and then the 1st term must be 5. So it said, write the first 5 terms. I got to do the 5th term. I didn't do the 5th term. That would be 25, adding 5, right? So I took the change in the numbers over the change in the number of terms to get my d value, and then I used that to kind of backtrack my way into the numbers. Now that wasn't too bad because I had the 4th term. It didn't take me too long to go down to the 1st term. But what if I said the 1000th term is 65 and the 933rd term is 20, find the 1st term? You would be going back for a long time. So there must be a quicker way. And a quick way to do it is actually to find the explicit formula. And if we can find the explicit formula, that allows me to easily find any term in the sequence. All right, so I'm going to help you out with this first one and kind of give you this general format for the explicit formula. So to find an explicit formula, it's simply going to be, oops, what happened there? All right, let me fix this. Looks like the dot got changed. And the color got changed. How did that happen? Let's see this. There we go. Okay. So the explicit formula we're going to use is a sub n equals, just so to find any term, is in this case 5 plus n minus 1 times 5. Okay. Which if I combine and simplify, a sub n equals 5 times, or 5 plus 5 and minus 5. I just distributed this 5, which if I simplify gives me 5n. And you can test that. Try plugging in 1, we get 5. Plugging in 2, we get 10, and so on. Try plugging in 4, we get 20. So that is my explicit formula, and that jives with what we did above, that the number in front of the n must be the d value. And I'm going to put this in more general terms in a second. So if you're like, where are you getting that from? I'll explain in a minute. Okay, but in this case, our explicit formula would be a sub n equals 5n. Recursive formula might be a little easier to come up with. We know that to find any number in a recursive sequence, take the term before it, and then add the d value. What's the d value? 5. And then just to get going, you have to give, as part of your formula, one number. We know the first term in the sequence is 5. So that could be an example of my recursive formula. A sub n equals a sub n minus 1 plus 5. And the first term is equal to 5. So a general formula for an arithmetic sequence, okay, general formula would be for explicit, okay, for explicit, okay, is a sub n, we know it starts with a sub n, equals a sub k. What does a sub k represent? Okay, it represents the value of a term in the sequence. In the previous case, we used 5 because I knew 5 was the first term. So value of a term in the sequence. Okay, and then we're going to add to it plus n minus k, okay, times d. We know d, right, is the common difference. And k, okay, notice I have k here, and I also have k here. K represents, okay, the place of the term. Okay, place of the term. And we're going to do example 2 in a second. I'll show you how we can kind of incorporate all this. And for recursive, it's going to be a sub n equals a sub n minus 1 to the previous term, plus the d value. Okay, and then you must give some term. So a sub k just represents any term, okay? And that's going to have to, you're going to have to give some number, right? So just like in the last example, we said a sub 1 equals 5, k would have been 1, right? So a sub 1, okay, equals 5. 5 is your number. All right, so let's take a look at example 2. So it says the first term of an arithmetic sequence is 4, and the 8th term is negative 45. Find the explicit and recursive formula of the sequence. First step in all of this, always find D, because D is part of every formula. Okay, so I'm going to start with the change in my terms, change in the number. So negative 45 minus 4. And just make sure you're consistent in the way you find them. If you put negative 45 first, make sure you put the place of that term first as well. So negative 45 was the 8th term, and 4 was the first term. So I get negative 45 minus 4 is negative 49 over 8 minus 1, which is 7. So I get negative 49 over 7, or negative 7. There's your D value. So now I'm going to use my formula for explicit. So to find the explicit, let's use that formula we used above. So it's a sub n equals a sub k. A sub k just represented a number, okay, any number in the sequence. So let's use the first term. So we're going to use 4. Remember, 4 was the first term, okay, plus n is your variable, so you leave it as n, minus k. And again, k represents the place. Let me change colors here. K represents the place of the term I put there. So what place was 4? It was the first term. It was the first term, so I'm going to put 1 there. And then I'm going to multiply it by negative 7. And then we're going to simplify this. So we have a sub n equals 4 plus, or let me just use minus. It'll be minus 7n plus 7, or a sub n, okay, equals 11 minus 7n, or if I want to put that first, negative 7n plus 11. That is your explicit formula. Conversely, watch what happens here. Okay, let's say you didn't use the 4 term and you said you used negative 45 to come up with a formula. You would say a sub n equals negative 45 plus n, okay? What term was negative 45? It was the 8th term, so we're going to put minus 8 in here, since negative 45 was the 8th term times negative 7. If we simplify that, we get negative 45 minus 7n plus 56, which if you simplify that, you get negative 7n, okay, plus 11. So notice you get the same thing no matter what term you use. Again, the critical thing is in your formula, make sure that if you use the 8th term here, you put minus 8 there. Conversely, if you put in the 100th term, okay, the value of the 100th term first, you subtract 100 there inside that parentheses, okay? And then the recursive, I'm running out of room, so let me do it up here. I'll do it in blue. The recursive would be a sub n equals a sub n minus 1 plus the difference, or in this case minus the difference, minus 7. And then I have to give a term. I have the first term. You could say a sub 1 equals 4. You could say a sub 8 equals negative 45. Either one would be acceptable, but that would be your recursive sequence. Okay. Number 3, you can try on your own. It's identical, just different numbers than 2. The solutions for that are on Canvas, so you can find them there. Your homework are problems 4, 5, and 6A and B. Okay. 6 might be a little bit tricky. Okay. 4 might be a little bit tricky, but it's very similar. Start with finding the D value. So for number 4, find the D value first. Find the formula first. So if I'm listing out the steps, what should I do here first for number 4? 1, find D. 2, okay, find explicit and recursive formulas. and then the last step, then find the 14th term. And use your formulas to find the 14th term. Don't count up, okay? You're going to be required to show me formulaically how you find a term using the formulas. You could, 14 is not high enough, or you could probably count it, but I want you to show me formulaically how you'd find the fourth term using the explicit formula that you come up with in step 2. So that's the steps I would use in problem 4. 5's a little bit quicker. I give you the formula, so that should be fairly simple. Number 6, I give you some information. It will be a little work coming up with a formula, okay? But I do give you the d value, so you don't have to calculate the d value. So if I come back here up to the steps for number 6, okay? Number 6, I already give you the d value. So you can jump right into step 2, and then step 3, which in this case is finding the 22nd term, okay? So work on those. Come to class with questions next time, and then you guys will be all set.